With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today's question is complete the following table using the concepts of VBT. So we have been given many coordination compounds and we have to complete the table using VBT. So what does VBT tell? VBT tells like this. That is, VBT tells that a coordination compound is formed. Coordination compound is formed by donation of lone pair from ligand to an empty hybridized orbital of the metal. So we have to make empty hybridized orbitals in metal and the ligand will donate its lone pair to that hybridized orbital. So that is VBT. So when we see this compound, we are being given compounds with coordination number 2, coordination number 4 and coordination number 6. So we can do it one by one. So first one, coordination number 2 compounds. Let's see. A is AG plus compound. So it is AgNH3 twice and plus. So NH3 is a neutral ligand and so the Ag will have plus 1 charge. So Ag plus implies what? D10 system. So D10 system means all the d orbitals will be filled and we will have we need two empty hybridized orbital for NH3 to donate electrons. So where can it be found? It can be found from sp, the next corresponding s and p orbital. So we get hybridization as sp. Hybridization will be sp, and hybridization will be sp means geometry will be linear. Geometry will be linear. So hybridization sp and geometry linear, and the number of unpaired electrons is 0 because D10, D is fully filled and we have 0 unpaired electron. And the magnetic moment according to VBT follows the formula mu equal to root n into n plus 2, where spin only magnetic moment, n equal to number of unpaired electrons. So it follows this rule. So when we see, we have 0 unpaired electrons in the first compound. So 0 unpaired electron basically means magnetic moment will be 0. So that's it. Next structure is CuCN2 minus, and we have been given it is linear. So it is linear means it will also have sp hybridization. It will be like Cu plus 1 oxidation state, as Cn minus is a negative anionic ligand. So it will have D10 and sp hybridization. So sp hybridization as it is linear, so it will be sp, and it is D10, so it will have 0 unpaired of electrons and the magnetic moment will also be 0. Next, AuCl2 minus. So third one is AuCl2 minus. So it will have Au in plus 1 oxidation state, implies again D10 system. It is similar to the same group as silver, so it will be D10 system and sp hybridized. So it will be again sp hybridized linear. So it will be linear sp and there will be D10, so 0 unpaired electron and 0 magnetic moment. Next, let's come to coordination number 4. Coordination number 4 compound. So first one is not first one, it is D. So we have D. D is platinum Cl2 NH3 twice. So Cl is an anionic ligand and platinum will have plus 2 charge. Platinum will be plus 2, which will mean it will be a D8 system. it will be a D8 system, and D8 system can have what hybridization? So it needs 4 empty hybrid orbitals, so it can have sp3 hybridization, and but it is given that it has 0 unpaired electron. 0 unpaired electron means d will be paired, d electrons will be paired, so it will have what hybridization? It will have dsp2 hybridization, dsp2, because it will be like we have 5 d orbitals, 1 2 3 4 5, and all the d orbitals have paired electrons, so d8 will be like this. So we have one empty d orbital here, and it will combine with sp to form dsp2 hybridization. So it will have dsp2 hybridization. So it will be basically square planar. dsp2 means square planar, and it will have dsp2 hybridization. 0 unpaired electron means 0 will be the n. Then next structure, so let's take next structure. So it will be I will just erase these parts so that I can draw it here itself. So yes, 1 minute. Yeah, so it will be like next structure is E will be like it is zinc CN4 2 minus. Zinc CN4 2 minus will be a D10 system, zinc 2 plus. So it will be D10 implies what? It will have D fulfilled, so it will have sp3 hybridization. So it will have sp3. sp3 means sorry, not sp3. Here sp3 means it will have tetrahedral geometry and sp3 hybridization, and 0 unpaired electrons and 0 magnetic moment. Next is CuCN4 3 minus. CuCN4 3 minus means Cu will be in +1 oxidation state, which is D10 system. So it will again have sp3 hybridization. So it will be tetrahedral sp3, 0 unpaired electron and 0 magnetic moment. Next one is MnBr4 2 minus. MnBr4 2 minus will have Mn in +2 oxidation state, which will imply it will be a D5 system. And D5 system, we are being given here 5 unpaired electrons. 5 unpaired electrons means D will be completely filled, so it will have hybridization of sp3 and geometry of tetrahedral. So tetrahedral sp3, and we have 5 unpaired electrons, so magnetic moment mu will be root of 5 into 5 plus 2. Root of 5 into 5 plus 2, so it will be around 5.93. 5.93 will be the magnetic moment. Next structure is CuNH3 2 plus. So it will have, if you see CuNH3 2 plus, it will be Cu in 2 plus, which implies it will be a D9 system. D9 system will have completely D occupied, so it will have sp3 hybridization, because all the d orbitals will be filled, and we are being given how many unpaired electrons? Nothing has been given, so we will have 1 unpaired electron, because the filling will be like this. So we will have, it is D9 system, so 1 2 3 4 5 6 7 8 9. So we will have 1 unpaired electron, and it will have hybridization of sp. So it will have hybridization of sp3. It will be sp3 hybridized and square square planar system. So it will have unpaired electron root 1 into 1 plus 2 root 3. So it will be 1.71. 1.71 will be the answer of the system. Next one is COI4 2 minus. So COI4 2 minus is again a D8 system. So it will be no, not D8, it will be a D7 system. CO plus 2 implies D7 system. So it is I. So it is a D7 system, and it has been given 3 unpaired electrons. So 3 unpaired electron means it will have like this 1, 2, 3, 4, 5, 6, 7. So there will be 3 unpaired electrons here. So the hybridization will be sp3, unpaired 3 sp3 hybridized orbital. So it will have tetrahedral shape, and it will have 3 unpaired electrons. So number of magnetic moment will be root 3 into 5, which will be around 3 point something 5 something. So that will be the answer. Next case is coordination number 6 complexes. So let's check the coordination number 6 complexes. So we have coordination number 6. First one is MnCN6 3 minus. MnCN6 3 minus will have Mn in plus 3 oxidation stage. So MnCN6 3 minus will have Mn in plus 3 oxidation stage. It will be a D4 system. And what else has been given? So we have been given there are 2 unpaired electrons. So 2 unpaired electron means it will have hybridization of D. It will have 2 unpaired electrons means it will have sp3d2 hybridization. So not sp3d2, it will be d2sp3. d2sp3 hybridization will be present. d2sp3. So we get d2sp3 hybridization for Mn nucleus, and it will have octahedral geometry. And d2sp3, 2 unpaired electron. It will be root 2 into root 4. It will be around 2.83 Bohr magneton will be the magnetic moment. Next compound is Cr plus 3. Cr plus 3 means here it will be D3. So D3 system, and we have been given 3 unpaired electrons. So it will be 3 unpaired electrons means it has 2 other d orbitals. So it will be D3 and D2sp3 octahedral complex, and it will have the magnetic moment as root 3 into 5, which will be around again 3.5, 3.6, maybe 4, around that value. Next is FeCN6 3 minus. So again FeCN6 3 minus, Fe is in plus 3 oxidation state. So it will be a D5 system. So D5 system, and we have been given there is only 1 unpaired electron. 1 unpaired electron means so it will be like the electronic configuration will be like this. So Fe plus 2 plus 3, and it's a D5 system with a 1 unpaired electron. So we will have structure like this: 1, 2, 3, 4, 5. We will have this will be the, so this will be the 1 unpaired electron. So it will have D2sp3 hybridization again, D2sp3 octahedral it will be, and the magnetic moment will be root 3. So it will be around 1.717. Next it is IR3 plus system. IR3 plus is a D6 system, and it has 0 unpaired electron. 0 unpaired electron will be means it will be again D2sp3, because the orbitals will be paired, the electrons will be paired, and we will have 0 unpaired electron. So it will be again be octahedral, D2sp3 and 0 magnetic moment. Next one is VCO6. So we will have 5 electrons. So it will be a D5 system, and D5 system with one unpaired electron is similar to that shown for Fe3 plus D5 system. So it will again have D2sp3 octahedral and 1.71 more magnetron, the magnetic moment. Next one is D6 system, Fe2 plus D6 system, and it has 4 unpaired electrons. So let's draw the structure. Fe2 plus D6 system with 4 unpaired electrons. So we need 4 unpaired electrons. 1, 2, 3. So let's draw the compound. So it will be like this. Here we have 4 unpaired electrons. So this would be the structure. So d orbitals are not empty. So we will have sp3d2 here. Hybridization will be sp3d2, and it will be again an octahedral complex, and the spin only magnetic moment will be around 5 or 5.1 something, 4 into 6, root 4 into 6. So it will be around 5.1 something, which is root 4 into root 6. So it will be that will be the answer. So next, MnCl6 3-. So MnCl6 3- will be a D4 system with 4 unpaired electrons. So since 4 of the orbitals are occupied, it will look like this. It will be a D4 system with 4 unpaired electrons. So it will be like this. So the hybridization will be again sp3d2. It will be sp3d2, and it will be a octahedral complex, and it has 4 unpaired electrons. So again its magnetic moment will be around 5.1 or something, root 4 into root 6, root 4 into root 6. So this is the complete table of the compounds using VBT theory. That's it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.